Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today I have a Class A amplifier. It's a 20 watt Class A amplifier. I think this guy is a nice size for Class A because they're so inefficient, and really 20 watts is a lot of power. Now it's rated for 20 watts into 2 to 8 ohms, so that's pretty nice that it goes all the way down to 2 ohms. So what we're going to do is we're going to power these guys up. Now, by the way, you can get these on Amazon. I'll put the link below. You can get them on eBay too. I'll put the links below. I think they're 75 bucks or less. So it's a nice little board, and it's going to fit on my box nicely. It has this big heavy heat sink on it, this big metal tab, and that's one of the reasons I got it, because it's one of the few that actually comes with a nice metal heat sink and large TO3 transistor packages. So, I mean, you don't always see the big, large TO3s anymore. Motorola made some really good ones back in the day. Motorola became ON Semiconductor, and that's the name on these. You know, whether they're real or not, who knows these days, but it says made in Mexico. Maybe, I don't know. Anyway, we'll see if they work. Now, it also came with these large 5 watt resistors, which is awesome, because so often I see the Class A amps, they just don't put big enough resistors. Now, these resistors are kind of what forces the transistors to share. There's 4 of them. There's 2 per, there's 2 on the positive side, 2 on the negative side, so they're in parallel. So that's how you can get the power. For 20 watts, that's a nice setup, I think. It also has a smaller transistor on the heatsink, and they mount that up right on the heatsink and right in the middle, actually, so that the temperature affects this small transistor like it does the big ones. That way the bias network can track with temperature. So pretty cool. And the pot right there to set the bias is right near the bias transistor. Just from what I could see, the photographs and the parts that they used, from what I could tell, it looked like it was worth the money. So I wanted to get one and try it out. So they come in a pair. And they just came in this box with all this foam, and yeah, it came just fine. And anyway, yeah, just wrapped up in this heat shrunk plastic. So we'll take this off. We're going to bring the camera over here so you can get a nice close-up. There's an air coil that you can know. There's a couple transistors on heat sinks. These are probably the drive transistors for these guys. And there's some other transistors on the board to set up, other bias networks and that. And then there's an op amp for the preamplification. So it kind of simplifies the circuit, and the output stages are only 2 stages. So pretty simple. They say there's no feedback. I'm going to try to pull down a schematic. The schematic I could find had really poor resolution. So I'll see if I can get a better resolution schematic and show it to you. Okay? But here, for now, let's come over to the bench. We're going to set up the bias. And I might just use these power supplies. I had this guy all set up to use. This big old capacitor bank with the bridge rectifier. This board takes the DC input, so you need to supply your own bridge rectifier, and then I have a toroid here to power it too. Now the thing is with Class A, you don't typically need as many capacitors, as much capacitance, because unlike in other amplifiers where they kind of idle at low power and then they go range, from low power to max power, Class A's sit there and idle at half power. So the capacitors are fully loaded, and then they go to kind of a no load to a max load. And so they're already in the halfway position. So if that makes sense, the ripple, what you're going to get, is already going to be there. But what we're going to do is we're going to supply some big caps and a rectifier. So let's bring it over here to the bench and take a close-up of the boards, look at the setup. And then I think the first test I want to do is I want to run 1 watt like I did the Class D, and I want to do the Bode plot. And I want to see what the Bode plot looks like. I want to see what the phase gain looks like it, you know, I want to see where the cutoff frequencies are, okay? And we'll take a THD measurement along the way. And also, I want to take efficiency at 1 watt. It'll probably be the worst at 1 watt, but, you know. But, and then, yeah, we'll see if we have time to take it up in power too. Or that might come next video. All right. Hey, thanks, guys. Let's come over, bench, and get started. Well, and this is the way it came packaged. And this bubble wrap kind of protect like this. The heat sinks. You can see the heat sink, it extends all the way back here. And this is the board right here. So you see how thick it is here. And it's still fairly thick right through here even. Pretty nice design, I think. Pretty beefy. See the air coil right here? That's so you don't have saturation with some kind of ferrite or some magnetic material in there. So it's just air. You can't saturate it. These are the big 5 watt resistors. So we have our input power here. The output's a little difficult to see, but it's right down in there. Here, let me take this plastic off. Sorry about that crunchy sound. Kind of irritating. There's the LED right here. There's the pot that we can use to set the bias. And that's nice little close-up of the board. So by the way, these holes, if you can tell, it's a larger diameter here, and then it drops down into a smaller diameter, so you can sink your screw right down in there. And probably can't tell that's a smaller diameter. See, my lead can't quite go into that, the rubber part. But on this side, it can sink all the way down in there. So yeah, that gives a nice, you know, place to let your screw head sink right down in. And then if you can tell, there's the mica insulators underneath the transistors, and they use some white thermal grease as well. You can kind of see it gushing out on a couple of these. Now, you don't really want to see it gushing out everywhere. You don't want a lot of that. It should just be a real thin film just to fill air voids between the metal and the plastic. You don't want a layer of that thermal paste. It's going to be resistive. So, but it's less resistive than air. So the air pockets between the materials, all you want to fill in. Here's a little transistor sitting on the heat sink so that the bias can track the temperature of the heat sinks. And you can see the poly caps, the yellow and blue caps. Aluminum electrolyte. Here's the op amp here at the end. That you get a nice close look at that if you like. See the transistors on the heat sinks there. That looks like a 2K pot. And you can see the transistors right next to it. You see the poly cap down here, the blue one over here. And these yellow guys are poly caps. And there's the output, the positive output right down in there. So the back side of the board, you can see the bolts here holding the TO3 cans down. You can see the heavy traces underneath the masking there. Alrighty. Alright, I just wanted to show you something. I've got my Havotest, or the otherwise known as the Kaiweets, I think, HT118A. Look at these cool probes. I did a review where I showed these probes. They're really inexpensive. I think they're 10 or 11 bucks. Silicone, big heavy silicone leads, nice. I put this crazy long gold tip on just to show you. And then here's the normal size, and there's the little kit that came with it. Just wanted to remind you guys that there's these probes out there. You don't need to spend a lot of money on silicone probes. What I want to do is show you the input. See that pin right there? This thing's so long, but that's the input pin right there, right? The pins are really small. Well, so it goes to the resistor right next to it. See that? 0 ohms. Okay, then it goes through that resistor, 2.2K. Then on the other side of that resistor, we have 0 ohms. So it goes straight into the op amp. So the point is, there's no capacitive coupling. It's a DC inject right into the, there is a little, looks like there's a little filter here with this capacitor. I think the second resistor over, and this capacitor sets up a little filter on the input for high frequency, but otherwise low frequency or DC is going to go straight in here. So you want to make sure you don't have any DC coming into your amplifier. The nice thing about that is it allows you to set up where you want your crossover, your low frequency to be with your preamp or whatever. If you're going to feed the signal directly into here, you'd have to go through a capacitor if you're worried about DC coupling. Okay, the other thing I was interested in is the potentiometer right here. Just wondering where it is right now. I would suspect if they did any testing at all, they might have set that up for me already, and we can still play with it, see if it's set optimally. But anyway, it's right there, so we look for 3 pins, and it's those 3 pins there. So if I go across here, okay, it's set up for 294 ohms. If I go to the middle one, okay, that's the wiper right there, 296 ohms or whatever it is. 296 point, it's almost 297 ohms, I guess. If I go between those two, it's 0. So it looks like the wiper's tied to the top, to this pin over here. Okay, I'm going to do something here. Now, I'm going back to this pot. Now I notice it jumps right in at 295, and then it kind of, I don't know if there's a capacitor in there. Something, it looks like something's charging. So it settles down right around 298. 298.4.5 is it? Okay, so it settles in right around 298.6, we're going to call it. What I want to do is, when I adjust this, I want to know if I'm going up in impedance or down. So I'm going to take it and make one full turn clockwise just to see which way I go. Right there. Okay, so clockwise it increases the resistance. So that's good to know. Before I start messing around, I don't have to do it with power on it. Alright, so we're going to play with it a little bit when we get it, when we turn it on, and when we do, we're going to keep track of, you know, half turns, quarter turns, whatever, and we'll keep track of which way we go and how many turns. So right now, it's turned, you know, we'll just be mindful of the angle of that, okay? Okay, there's one more thing I wanted to confirm, and that, I started putting my test wires on. The center post is not identified, but I know there's a trace on the top side. The bottom side there's not, but I just want to go to ground because that should be ground. And it is, okay? Now you notice I didn't put on continuity. I could have got a beep, but what if there's 10 or 20 ohms in there? I want to make sure it's 0, so, and with continuity, if I keep an eye on it, show me that too. Yes, I thought I'd demonstrate that. So this is continuity. I'm gonna hear a beep, but I'm looking up to make sure it's 0 ohms. And I see a green light up there saying it's short, but I'm gonna look anyway. That's why I didn't bother to go to continuity. Just want to point that out. Okay, let's just go over this setup. As you can see, I have voltage applied. I have things running right now. Sorry about the fan noise. You can see I have it running just here. I'm going to bring it right at 25 volts. There we go. Okay, right at 25. Minus 25. These leads are plugged into these two stacks of connections, and this one right here is the negative voltage coming into this terminal block. And this guy here, this stack right here, is the ground connection, that terminal block. And then the red alligator underneath is tied to the plus. And that one has two leads coming up to this meter, reading plus 25 volts. And this one's reading the minus 25. So we got plus minus 25 at the input. I soldered a wire down to that speaker output, and got this. I'm using this alligator to clamp this load to it, and then the other side is tied to the ground. Okay, so all the power stuff is right here, all the power ground is right here. Then the ground goes through the board up here to the input, and so you can see I'm using scope probes here. Scope probe on the output, scope probe on the input. Grounds are tied together, so my scope probes are safe to be tied like this. And my generator, I'm using a couple resistors or whatever, some parts just to clip onto. So I've got the signal coming in from the scope, and I'm monitoring it with channel 1, and channel 2 is this scope. Okay. Alright, so let's just go check out the power supply. Oh, and by the way, this is my 200 watt 8 ohm load, so that's great for this test. And I just propped it up here so my light wouldn't shine on it too much. So, oh, that works too. This mat works great because it, has a really high melting point, so I can let things get hot on it, and it's fine because it's just silicone, so it's great. So anyway, okay, there we go. Now let me show you the power supply. All right, and this is the power supply I'm going to use. For a moment I thought I might use these two guys in series for the plus minus voltage, but this guy has enough power and it just makes it easier. So I use this GWN stick, and I've got this meter. Light makes it hard to see, but I got that meter reading current. This switch goes over here, so see they're both at 25 volts. It says 24.9, 25 over there. Put current 0.33. If I move that current, they should, yeah, they're 0.32, 0.33 on this side. So yeah, that's how I can set it up so that this tracking power supply will make it easy to watch the meters. The one benefit of the Kaiweets is you have to dial them both up at the same time, so that's the disadvantage. But the advantage is you have nice voltage, current, and watts on both outputs. So I did a video where I showed these as kind of a poor man's tracking power supply with lots of current capability. Alright, now let's go to the scope and take a look. Okay, this is the signal running through the scope real time. Everything's powered on right now. Here, let me get over here and show you. So channel 1 is the yellow guy. And here, I'll get those windows out of the way. And it's 83.3 millivolts in right now. We're set up for 1 kilohertz, 1 watt. So you can see 1 kilohertz, and the output's about 2.84, which is about 1 watt. And obviously, 1 kilohertz, the phase is going to be perfect. I mean, well, it should be. Class A amp should be, right? Okay, so everything's looking pretty good. The next thing we're going to do, see my generator 1 is what I'm using. Yeah, even at 1 watt, I can smell the amplifier, the heat sinks. Ooh, it's starting to get toasty, actually. Wow. I mean, we have 25 volts on each output, and each output's putting out 0.3 amps. So yeah, we're putting out some wattage. Okay, and you can see we're at 0.03% distortion, 0.02 something to 0.03. It's kind of bouncing around. But if we go to measure, see we're reading THD. And if I go down to harmonics, we're going out to 12 harmonics, so we're picking up a lot of harmonics, and that should be good. So that's our THD at 1 watt. Okay, let me go through the setup real fast. Okay, so we know we're putting in about 83 millivolts. Okay, let's go to our application. I'm hitting the application button on the scope, and it comes up with this, and I want frequency response now, so I come over there, select that. Yes, I want to do it. Okay, it's showing me the signals that's coming out right now, but let's go to setup. Inputs channel 1, yes. Outputs channel 2, yes. And that's good because this shows how the setup is. The device under test. Generator 1 is what I'm using. Input with channel 1. I got it set up just like that, but you don't have to. And generator. So I want to do, well, we're 80 millivolts, so that looks about right. We're going to start at 20 hertz. Okay, and we're going to stop at 100 kHz, I think. Okay, that's 100K. That looks good. Because we don't know how far it's going to go. I want to go all the way. So, okay, I think we're ready to run it. Alright, I just shut down the power amplifier and the power supply so it'd be a little less noisy. Okay, so let's go to scale multiplot. Let's go to phase first, and let's put a 0 degree out here. Okay, I'm changing the scale right now. That's 15 degrees per. We can really, let me see if I can go, yeah. So 15 degrees, that's best resolution I can get there. So let's go phase offset, and let's get an even number there so we have a 0. Put that on 30, I think. Okay, so this is 0 phase. So it's pretty much 0 phase, and then it went to 15 degrees out at about 20-30K. So at 20K, I don't know. It's like 10 degrees out. So, that is pretty darn flush. And the gain, well, here, instead of doing that, let's just do this. Let's get cursors on. Cursor 1 selected. Let's leave cursor 1's over there. Cursor 2. Okay, so they both start off right now at about 4.2 degrees and about 30.43 dBs. And as I move across, you can see the delta. It's like right there at 0.2. That's as big a delta as I've seen so far. 0.7 right there at that peak. So it's less than a dB. That's pretty darn flat. Okay, let's go out to 20K. Right there it's 1 dB. And 20K we're about 0.8 dB. So yeah, that's looking pretty darn good, guys. Here, let's go all the way over here. Jeez. It's still, okay, out to 100K, it's 1.3 dBs. Man, that thing has some bandwidth. Wow, that's impressive, I think. I'm just going to leave those at 20. Wow, like that. Alright, so that's your plot. Pretty nice. Okay, I got it back running again at 1 watt, and what I want to do is, take it up and just see. We're going to take up the generator, and we're going to just see where the thing clips, okay? Oh, there it is right there. Now the top side's clipping, the bottom side's just starting to. But let's just... Okay, right there is just before clip. Get rid of all that stuff. Okay, that's what it looks like. And by the way, distortion, THD is 0.145. Oh, looks pretty darn good, right? There's no crossover, it's Class A. Okay, I took the output up to, or the power rails to 28 volts just to see if we get a little bit more power. Okay, goes to like 6% right there. And if I go right there, it's one more notch, it's 0.05 or 0.06 THD. Right there's 0.145. So that looks like it's just before the THD gets bad. Let's go one notch over. Let's creep it up. Right there. So we go right up to there, 0.185. You can visually see it, and it goes up to about 1% distortion right there. Right there, that's almost 1%. So yeah, that right there is our max at 28 volts on the rails. So we're almost 8 watts. That's only 8 watts, but it's 8 watts, Class A. And by the way, the power supply is up to 0.5 amps. So it doesn't change much. That's why you don't need a lot of capacitance on the Class A, because you're already running it, you're already running it pretty hard. Alright guys, I just thought, what the heck, man. Let's put a 4 ohm load on it, and let's see if we can get the same amplitude. Okay, so I've got it on frozen display right now. I'm going to turn that off. So we're just free running. I'm going to bring up the power supply. Okay, and power supply is up. It's about 25.5 volts, because I think we'll probably drop some voltage maybe. Okay, here, let's turn on the generator output. We might drop some voltage on the leads to the board. There's our amplitude. Okay, let's start increasing that. Okay, there we go. Same place, so that's good. We can go right up to there before we get before our clipping. So yeah, that's great. That means we have good dynamic range because we can hit the same peaks. I'm going to freeze that. Now hold on, let me take down a little bit more. Okay, we're about 0.3. We're about 0.35 THD right now with 4 ohms. I'm going to just freeze that. And I'm going to turn off the... Oh, okay. The power supply is up to about 0.8 amps right now. Alright, hey, so what do you think of this amp? 20 watts. It's rated at 20 watts. From 2 ohms to 8 ohms. So I wonder if that's 20 watts into 2 ohms. Because in 8 ohms, we don't get close to that. And I think I'm putting in the right input voltage. I'm going to check on that. The one thing about this board, it did not come, and it did not have a lot of specs with it on the, on Amazon either. It just looked like a good board, and they said 20 watts, and I'll show you the schematic next time. We're going to do a little more serious testing, a little more serious power testing, and run this thing through some more paces, because I'm thinking about putting it in this box down here. It fit nicely, and the amount of dissipation, actually, I mean, even though we're only putting out close to 8 watts, and now 4 ohms, it was not quite double that. I think I could probably get there, I'm not sure. But anyway, it's only about 20, well, I'd say 30% efficient. So Class A, that's kind of what you expect, right? So it is going to get hot, and you know, in this little box I have, I think it's pretty nicely sized, and if it did put out a full 20 watts, it might be too hot. And I don't know how much music volume you can listen to, right? I mean, you know, 1 watt, when I do 1 watt tests with music, it's pretty loud. So what do you guys think? Hey, by the way, give the video a thumbs up if you like it. That helps the YouTube analytics a lot, you know. Yeah, it just helps. So appreciate that. And well, I'm saying I'm appreciating people. Let me appreciate the patrons. Thank you guys. Really do appreciate that. Thumbs up to you guys, and thumbs up to everybody watching the videos and supporting and comments and all that kind of stuff. Let me know what you guys think about the power level. I'm kind of debating between the Class D amp, which I can get 100 watts easily per side, or this one, which is probably going to be closer in the 8 ohms, 8 watts. I think it's going to be a pretty stiff amp. I mean, I think, you know, as far as being able to give good solid power out at 8 and 4 ohms, and music power is a lot different than, you know, test bench power when we're doing sine waves. You know, music's not sine waves, continuous. It's all over the place. And so anyway, we'll do a music test next time, and we're going to do some power. We're going to listen to some music and see how loud it really is. But let me know what you guys think, okay? Because I'm really curious. I'm kind of teetering on, should I build this amplifier, this Class A amp, in that box I have. Here, let me show you the box. Oh, there's the box. So this guy would fit in it nicely. Do I do that? Or do I put the Class D amp in it? I have the right size of toroid for either one of them, I think. So what do you guys think? Let me know. Hey, thanks for watching, and next video will be on this amp again. We're going to do a few more tests, because I got to decide which one I want to put into that box. So, I mean, from a purist point of view, I kind of feel like putting this guy in, but I don't know. What do you guys think? Let me know. Alright, thanks for watching, and we'll see you next time. Alright, thanks. Talk to you later. Alright, thanks. We'll see you later.